Training a powerful model from scratch takes mountains of data and millions of dollars of compute, so almost nobody does it. Instead, we take a model someone else already trained and adapt it to our problem. It's the single most practical idea in applied machine learning: transfer learning. Here's the problem: a modern model has billions of parameters, and to train one well, you need enormous datasets and weeks on thousands of GPUs. For your specific task, sorting your company's documents, spotting a defect on your production line, you have neither. Starting from random weights is hopeless, but you don't have to. First, someone does the expensive part once. They take a giant model and pre-train it on a vast general dataset, all of the web's text or millions of images. Through that, the model learns broadly useful structure, grammar, objects, edges, concepts. This is the heavy lifting, and it's already been done for you. The key insight: what a model learns is mostly general. The early layers of an image model detect edges and textures, useful for any visual task, whether it's medical scans or satellite photos. A language model learns grammar and meaning, useful for any text task. Those learned features transfer from one problem to another. So we fine-tune, take the pre-trained model and continue training it. But on your own small dataset for your specific task, the model doesn't start from nothing. It starts from broad competence and just specializes. A few thousand examples can be enough, where from scratch you'd need millions. A common recipe: freeze the early layers, keep their general features intact, and retrain only the last few, plus a fresh output head for your task. The bottom of the network already knows how to see or read. You're just teaching the top what to do with that knowledge. Less to train means faster, with far less data. It works because the hard part, building a rich representation of the world, is shared across tasks. Recognizing that an image contains fur, whiskers, and pointed ears is useful whether you're labeling cat or lynx. Transfer learning reuses that understanding and only relearns the final task-specific mapping. This pattern is everywhere. For years, vision teams took a model pre-trained on ImageNet and fine-tuned it on their own images. In language, BERT and its kin were pre-trained on huge text, then fine-tuned for sentiment, search, or question answering. Pre-train on the general, fine-tune on the specific. It became the default workflow. But fine-tuning a billion parameter model is still costly, and you'd need a full copy per task. So came parameter efficient fine-tuning. Freeze the entire pre-trained model and insert tiny trainable modules, adapters, or the popular LoRa. You train just a few million extra weights instead of billions. Same adaptation, a fraction of the cost. This flipped how AI is built. Instead of one model per task, we now train a few enormous foundation models, pre-trained once on everything, and adapt them to countless downstream uses. The expensive pre-training is amortized across thousands of applications. GPT, CLIP, and their relatives are exactly this: bases to build on. And the largest models go one step further. Sometimes you don't fine-tune at all. Show the model a few examples right in the prompt, that's few shot learning, or just describe the task in words, zero shot, and it adapts on the spot with no weight updates. The knowledge from pre-training is so broad it can be steered by instruction alone. Step back and a principle defines the modern era: pre-train once, adapt everywhere. The heavy general learning happens a handful of times at vast scale. Everyone else stands on those shoulders, fine-tuning, adapting, or simply prompting. It's why small teams can now build with capabilities that once required a research lab. So that's transfer learning. Take a model that already understands the world and specialize it for yours by fine-tuning, by tiny adapters, or by prompting alone. It's how applied AI actually gets done. But a pre-trained model only knows what it saw in training. Next time, how we give it fresh external knowledge on demand, retrieval augmented generation. See you there.